In this video, for Lesson 15, we're going to look more at polynomial equations. Polynomial equations can be used to model a variety of real-world applications. There are a variety of strategies that can be used to solve these types of polynomial equations. So we're going to take a look at some. Example 1. Representing a problem with a polynomial model. France's family is planning to build another silo for grain storage, identical to those they have on their farm. The cylindrical portion of those they currently have is 15 meters tall, and the silo's total volume is 684 pi meters cubed. So what are the possible values for the radius of the silo? To start this question, we are going to draw a cylinder to represent the silo. From the information given in the question, the height of the cylinder is 15 meters. Step number 2. Determine the formulas that can be used to determine the total volume of the cylinder. This formula will determine the polynomial equation that will represent the volume of the silo. In our example, we can say that the total volume, which is given by the formula pi r squared h, is 1/2 times 4/3 pi r squared. From there, we're going to substitute the given values for the volume and the height into the formula. So 680 pi is equal to pi r squared times 15 plus 2/3 pi r cubed. From there, we just reorganize. 684 pi is equal to 15 pi r squared plus 2/3 pi r cubed. Now, we want to look at how to simplify the equation. So to do that, we are going to set our equation to 0 by moving all our variables to the right. And then we get 15 pi r squared plus 2/3 pi r cubed minus 684 pi. Now, from that, we are going to take out a common factor of pi over 3. Now, when we do that, we get pi over 3, 45 pi r squared, plus 2r cubed minus 252. From there, we're going to multiply both sides by 3/pi. And why we've chosen the value 3/pi, it's the inverse of pi over 3. This will help to simplify the question. So from there we get 0 equals 45 pi r squared plus 2 pi r cubed minus 2052. Now we do know that when we're solving equations, we always write them in descending order of the degree. So our next step is to take 0 equals 2 pi r cubed plus 45 pi r squared minus 2052. Now this looks like the type of equation that we would be able to solve by factoring. And we have, again, set it to f at r because that's our variable. So 2r cubed plus 45 pi r squared minus 2052. Now, we begin to use the factor theorem that we've been looking at to determine one factor. So to do that, we're going to test if factor 2 will work. So we substitute in 2 for the values of r, and we find there's a remainder. So that means it is not a factor. All right, let's try 3. So then we look at substituting 3 in for r, doing the math calculations, and we get negative 1,593. Well, that doesn't work either. So let's try 6. So now we have 2 times 6 cubed plus 45 pi times 6 squared minus 2052. It's equal to 0. So now we know that using 6 as the value for r equals 0 is working, which means it's now one factor. Now, moving on, you can either use long division, which I've given you, or you can use synthetic division, which is also shown here, to determine the factors. You can choose which method you work out the factors with. And so from there, we find that r is negative 8.6 and r is negative 19.9. Now, since the radius cannot have a negative value, these two factors cannot be used. But we also had r minus 6 equal to 0, which we kind of overlooked, but because it was a little, okay. So we get r equal to 6. So we did this work with our quadratic formula to see if there were any other factors, and we have found that the factor was 6. So what does that tell us? That tells us that the silo must have a radius of 6 meters. Now, let's move on to a next example. In this example, we're going to select a strategy to solve a cubic equation. And here is the equation we're going to take a look at. 4x cubed minus 12x squared minus x plus 3 is equal to 0. So we're going to start by trying the factor theorem. So we write down step 1. Solve the equation by factoring the polynomial. F at x equals 4x cubed minus 12x squared minus x plus 3. Step number 2, we're going to use the factor theorem and the related polynomial function to determine one factor. So we want to determine, that means we want to determine the possible values for x where f at x is equal to 0. Now I've given you a little hint here. Numbers that can make f at x equal to 0 are of the form p over q, where p is a factor of the constant term, and in our equation that is 3, and q is a factor of the leading coefficient of the larger variable x cubed, which is 4. Now, we can then get a range of values. Using these values, we can substitute them in to see what's going to work. So we'll start at the left and we will try the factor 1. No, it came out to -6. We'll try the factor -1. No, came out to -12. Let's try 3, which is next. And when we substitute in 3 to the equation and get 4 times 3 cubed minus 12 times 3 squared minus 3 plus 3, it works out to 0. So now we have one factor, x minus 3. From there, we can set up long division, we can set up synthetic division, or if you have another way, there you go. So when we substitute that, when we set up